All right. Max, thank you so much for joining the Scientist Spotlight. Why don't you tell the community about yourself? Tell the Superbio community about yourself.
Awesome. Yeah, thanks for the invite, Berker, and happy to be here today. So I am originally from Germany, as you might tell by my accent. Actually was from when I was little, I was quite enamored with becoming a physicist, studying the natural world and such. That's what I did in university as well. Then did an undergrad and actually a master's degree in physics. Somehow got sidetracked into biology during my master's degree because you had to do a lot of experiments doing your master's degree, and the experiments in physics, they were all like 50, 40 years old, whereas the biology experiments were all like a few months old and like all didn't work. And you had to like kind of figure it out on the fly. So we spent like whole days in the lab, whereas the physics experiments were like you go in, you do your 1 hour experiment, and then you're out again. So it was way more fun. Then was kind of enamored by neuroscience, went to Cambridge for a PhD in cellular neuroscience, where I then had to do a lot of imaging, like like cell biology, cell imaging, and such. And then because I'm lazy, started building a lot of software to like automate image analysis. Published a few of these things. Then suddenly people wanted to pay us, me and my colleague, for developing our own software, like our own special pieces of software for them. And suddenly we had a consultancy business. And then I just finished my PhD. We continued with the consultancy business. And that then became Deep Mirror today. So it's a bit of a different founding story, I think, than most companies. So we first just suddenly had to set up a company because people tried to give us money. And then afterwards we had to figure out like what is actually a scalable business.
That's music to my ears, to be honest. So I heard theoretical physics. I heard neuroscience. Where did AI come into the play? What led you to pursue a career in AI and life sciences? And I'm also curious, what's your biggest motivation to stay in the field?
Yeah. I mean, there's of course the starting reason, and then there's the reason that you tell yourself later to,
Hmm.
yes, reduce cognitive dissonance. And this starting reason was definitely AI as a tool. I had to analyze a lot of like images that were super noisy and very like, the only way you could do it was by hand effectively. And then I started doing that a lot and doing a lot of screening and always having to analyze the same stupid images by hand. And then I just figured, okay, if I just build a neural network or like use some sort of pre-made algorithm that can probably help me doing that much faster. I implemented that, and it was like the first time like actually went quite deep into the architecture, started building my own loss functions, completely unnecessary, but just because it was interesting. I guess in your PhD you have a lot of time for these kind of things,
Hmm.
and that was then yeah, how I encountered AI. So mainly as a tool. Then initially with the company, we also did a lot of image stuff. Now we're not really doing that much image stuff at all anymore. And now in hindsight, I think if you look at what is happening in general, and for me, especially as a physicist, that's super interesting, is that in the last century, so to say, we built a lot of like super intricate and specialized models of the world that all were very beautiful equations that all work really well, predicting the movement of the stars, the universe, and whatever. Um, Now we concern ourselves much more with like super complex systems, such as cells, such as molecules or aggregates of molecules. And these turn out to not be that easily describable anymore with the methods that we used previously. And I'm quite excited by almost this shift of ideas now going more from this like first principles reductionist approach to, okay, if we just collect the right data, maybe we don't have to worry too much. Like because AlphaFold 3, for example, now it doesn't actually use any physical modeling anymore. It just uses data and just random blobs in space to kind of figure it out. And there's some cool publications that come out all the time around this, where even you can find very simple equations easily with machine learning ones. So you can almost think of an alternative universe where nobody ever wrote down any physics equations and you just collect data, automatically build models, and don't really worry about these models and just test edge cases. This is why I'm staying.
Yeah, I frequently read about the tension between physical modeling versus deep learning modeling, and often the best way to go about it is kind of mixing. and using sort of the best
For
parts of
now,
both.
for now,
For now. Well, where is it going to go?
I
Do you
think it would just
anticipate
go all the way to data,
all the way
because
to data?
there's only so much our minds can grasp, and then from that on, maybe we're not actually that good at modeling things, especially complex
Yeah,
things. We're good at
yeah,
being creative, coming up with new ideas, thinking about which data to collect, so what questions we want to answer, but maybe not at the modeling. Like, I mean, I cannot even grasp the standard model of particle physics, right? It's like these 10 or 15 equations, or you can write it on a t-shirt or something like that. But if you look at these equations, they're absolutely meaningless, which is why the question that people often pose about AI is like, oh, is it explainable or something like that? It's also not that interesting, because I mean, I don't think the standard model is that explainable either. So
interesting. And were you at all computational while you were studying theoretical physics? Because one of the questions that we have is, which came before for you? Is it the computational sciences or the biological sciences?
there was, of course, like a little bit of programming during the physics degree, but I think it was biology first. And then I only started thinking about computational work as a means of analyzing my data, very much from a data scientist perspective originally. So thinking of it first and foremost as a tool. I think then afterwards, I got maybe a bit too enamored with the technology itself. I became quite tech driven, quite solution oriented. And I hope I'm swinging back to like a more, let's say, middle ground again right now.
Well, I'd love to shift gears a bit and ask you a little more about your work, Max, starting with Deep Mirror. I know you previously mentioned the highly unusual situation that people were offering you money before you actually started a company. I wonder if you wouldn't mind taking us through that journey in a bit more detail and telling us how you became an entrepreneur.
Yeah. Um, So one day we published a paper, which, I mean, if you think of it in the most simple way, was essentially a piece of code that analyzes lines in images. So you have an image, there are lines in that image, and they all go from the top and the bottom. They might crisscross each other. And in neuroscience, you kind of collect these images to look at the dynamics of transport in nerves. And people kind of struggle with that because getting all these crisscrossed lines right is a bit difficult by hand even, right, let alone with a piece of software. So we published a piece of code which was like super bespoke for this particular application, and then we made it available online as an open source repository. But then scientists that couldn't do code came to us and asked us for custom deployments of that code, so like web form interfaces. I think similar to what you guys are doing at Superbio, right? We just take open source code and like drop it onto the internet essentially, and then we didn't really want to do that as terms of academic collaboration, so we asked them to pay, initially thinking that they would not because they're academics, but we didn't quite think that these were academics that came from the US. And I think in the US people have a bit more money to spend, or a bit more trigger friendly as well. So suddenly they were willing to actually give us real money for this. And then that was when we had to incorporate the company. And then we had this as like a little bit of a revenue stream where we did like sometimes custom deployments and asked people to keep paying like a yearly fee to keep accessing these deployments. Then on the side, we then, because I mean, that was maybe something that 50 labs in the world can use, right? It's not really something that does anything for the wider industry, or we never had any industry interest as well for this. And then we started working with a few companies and labs on custom image analysis deployments, then more and more molecule design analysis. So we basically, people have a bunch of molecules. Can you give me a bunch of other molecules that are like more soluble, more active, more whatever, really? And then in this, we actually started first working with enzymes, oligonucleotides, more, let's say, complex molecules, and slowly gravitated more towards like classic medicinal chemistry, because it turns out almost everybody does small molecule drug design. So kind of the money and the industry took us in that direction. And then at some point we decided, okay, it's enough with these consultancy pieces of work. Let's just build a piece of software which then required quite, as I mentioned earlier, around thinking less like a technologist and more somebody who just wants to solve a problem, required us to shift gear quite a lot by trying to think more about like how we actually present these technologies to people and less about the actual nature of these algorithms. We became kind of a very product focused company, and now we don't have any consultancy deals anymore, and basically just have paying users on the app that pay for access. Of course, like a super vertical app, like very specific use case. But yeah, as you can imagine, that was probably my longest answer so far. So it was like quite a long journey going from random line analysis and images over maybe some cell morphology analysis. We had some stuff in AgTech, then some stuff in enzyme optimization, all the way to small molecule optimization and small molecule drug design software. Yeah, but that's how it is, I guess, if you start out in the way that we did.
Well, that's really interesting, Max. Thanks for that. It sounds like you all have been incredibly flexible across use cases for the life sciences landscape. Along that vein, in the last year, we've seen generative AI and particularly large language models explode. I'm wondering how your work is, if at all, influenced by what's been happening in generative AI and LLMs.
I'd still say we dabble. Like as an organization, we of course try out quite a few of these tools. So I, for example, I see we don't have a recorder in here, which is unique, but I tried these recording tools sometimes. I think the generative models tend to be quite verbose, so I don't really like the way they write. So I can't really use the content that is created afterwards. So I prefer to make my own notes, for example, and I stopped that. Some of us use it for coding, but then others feel like it actually doesn't add much because then it's sometimes wrong, and then trying to figure out where it's wrong can be a lot of pain as well. So we're still trying and figuring out how exactly, but I think everybody is trying. Everybody is trying to find use cases because clearly it's like super exciting and there's a lot. And I feel like we probably have some proof points that it works really well in the creative industry, like generating content that doesn't need to be that precise in a way, right? But as soon as things have to be precise, and as soon as you're competing against humans creating the much cheaper scale, I think somebody even did like a calorie conversion between human brain power and generative AI electricity cost, then actually it gets a bit difficult sometimes, right? So yeah, we're still observing in terms of in the way we use it in our product and internally to explore generative AI for generating molecules, like ideas, right? Our software is a piece of software that basically helps chemists come up with new molecules and figure out which ones they should be testing next. There's some generative aspect of this. But then to be honest, like very often, it's again quite difficult as soon as you come up with a proper benchmark or a baseline of like, for example, I don't know, I just generate a bunch of molecules based on the last 100 years of medicinal chemistry knowledge, or with a custom diffusion model or something like that. More often than not, the more modern version actually loses, right? And it's sometimes a bit difficult to figure out exactly where the value lies. But we're working on it. Let's see what comes. I think everybody's working for looking out for the use cases. The only thing we can be sure of is that NVIDIA might rise in price over the next 12 months. Still, everything else, I don't really know.
Yeah, we're betting on it. Yeah. Well, I'm curious, the context of your work. How does your as a theoretical in the day to day?
Let's say it's like almost more like if I need to, I can read myself into like all these papers about large language models, about diffusion models, and understand like the mathematics behind it if required. If we have to discuss it internally because there's something we want to try out. So I'd say the main usefulness sometimes is actually being able to read all these equations and like, being able to like maybe cut through the crap sometimes. On top of that, I think it's just the idea of like being quite experimental, trying to figure out if you can model things maybe in an easier way and really like, being more in a first principle kind of idea. But as I said in the start, I don't necessarily believe anymore that physical modeling is the way to go.
Right. Well, thank you for that. And as someone who's, really cross-disciplinary, I think, across, mathematics, machine learning, the life sciences, I'm curious to ask, what do you view as the most significant gap in our current understanding or capability for life sciences AI?
I don't I don't think we have an issue understanding AI necessarily, because in the end it's just like a bunch of nodes and the nonlinear model then can fit whatever, right? So if you just build a bigger model, I think like one thing we maybe learned over the last 5 years or so is that in the end, none of that thinky stuff really matters. If you just build a bigger model, more parameters, you win, right? So for example, we worked with a guy who works here at the stats department in London, and he's like doing this like super intricate Bayesian models of two model processes. And he said, okay, then OpenAI and whoever comes around the corner, they don't care anymore. They just hammer compute at everything and they always win. So in the end, like the models themselves are maybe not that difficult, right? Even AlphaFold 3 in some ways is simpler than anything that came before because it's just the transformer and the diffusion model. I think what is maybe the biggest issue in the life sciences particular is that the data is not that easily available, not that clean, not that not like accessible to everyone. Some companies have some data, other companies have other pots of data, and that's I think that is kind of something that is mainly hindering the application at this stage. And then of course also the general idea of like where does it actually add value, right? If I dream up a molecule with a generative AI model, does it actually help me? Does it get me to a patient quicker? Or can a chemist just do that just as well? And I should be bothered with different things, right? So it's a bit of the finding the right applications, but then on the other end, it's also really about the data. Being very, in some ways, AlphaFold was so successful, right? Because we spent years, decades, I think almost, to curate all that structural data, right? Which we haven't really seen so much with other kinds of modalities or other kinds of problems in this space.
Yeah, I think data is, all the doors open up to data and the access to data and being able to wrangle the data and being able to use the data and drive and being able to ask the right questions to the data, right?
It's also like I feel like people don't quite realize that how serious they have to be about data. Like in our consultancy days, people often came to us. They were like, "Whoa, we want to use AI," and we were like, "Okay, it's cool. So what's your process?" And we're like, "Oh, we have these oligos, and we want to know this property." And then we asked them, "Okay, so how many experiments have you done? So often have you measured this property? Oh, 100 times." And then, I mean, that's fine. How many more times do you have to measure this? Oh, another 200 times maybe. Then we're done with our project. Then that makes no sense. You just do these experiments, and then maybe if that property is relevant for something else later, you aggregate it. But you can't just like come around the corner and like hope that AI will solve all these things for you right now. Of course, now with like a more foundational model approach, people hope that it will become a bit easier with these smaller data sets. But I don't think that will be always the case. And I think there's way too much talk about AI and way too little talk about data, which I think they're kind of interchangeable, the two terms. And maybe more of a data focus might be somewhat more useful to think of it in this way and less in like this, because you can always build a fancy big models with billions of parameters. It doesn't really matter, right? But if you don't have the data, then it doesn't matter either, right?
Yeah, I think part of it is the biotech industry kind of lags behind other industries in digital transformation, right? So I think that is also part of the culture about how much data that you have to collect and what you can do with that data and sort of the discipline that comes or doesn't come with that. But I'm curious, looking beyond therapeutics and drug discovery, are there any subsectors of the biotech industry that is interesting to you, that excites you when it comes to AI having an impact?
I think one of the overarching themes that I'm quite interested in is anything preventative, anything that is less focused on when things go wrong, which is what our healthcare system is mainly set up on. Just for example, the other day I had a discussion with a potential insurance provider for the company, and I asked them if there's any packages about preventative medicine involved, and they said no. And that was basically the idea was like, if you get really sick, they will help you. But I mean, if I have cancer already, I might rather not have cancer, right? Instead of having cancer and being treated really well. I think there's, of course, the problem because if you are an insurer, you are not that incentivized to do preventative because then you keep paying, and then you can much rather just hope that they switch insurer before they get really sick, so that in the end you don't bear the cost of when the cancer comes. And I think there has to be some political shifts and also structural shifts to happen in order to also incentivize company building in the space a bit more. But I see some interesting obsessions emerge, in particular, but in the US around aging and such, where people try to lobby to make aging almost a recognized disease. We've kind of like changed this quite dramatically. So I think aging might be the first entry point there, where okay, if you say aging is a disease, you can get like reimbursements for aging related stuff. Suddenly all this preventative stuff is on the cards, right? And then a whole industry might spring up to be more preventative. So it's I find kind of interesting how you can leverage maybe changes in reimbursement to encourage these kind of like more preventative startups a bit more. But I'm just mainly waiting on the sideline on that one because I think there's a lot of shifts that still needs to happen.
How do you think about aging? Do you think it's a disease? Do you think it should be accepted as a disease? That would influence preventative medicine.
I think yes, because it would actually help us be more focused on preventative medicine. And I think it's a bit, I mean, I have many doctor friends, and in the UK in particular, and I don't know how it is in the US, the way the healthcare system is now set up, everybody just sees the worst cases and then they keep coming back. So you just see people that keep being very, very sick all the time. And if only something would have been done earlier, they might have never ended up in this state. But it's really just in an emergency kind of service at the moment. And I think I think aging, of course, first the super rich will be like mainly involved in that, of course, but it will be some trickle down effect, in my opinion, as well, which will then overall potentially to a better healthcare system. Yes.
Yeah, I agree. Okay, I guess I'm curious to hear. I mean, going back to your unusual journey, where you studied PhD and then next thing you know, you're building a company. I guess looking back on this journey, what advice would you give to researchers that are doing, grad school or still in undergrad, and they're looking to join and even make waves in the bio AI space?
I think I mean, I can only speak from my own mistakes mainly, right? And but like my main issue was really like not thinking long and hard enough about the problem solution fit. So you might have very many solutions, especially as an academic, you have all the solutions for everything, especially technological solutions, great publications, what interesting stuff. But in most cases, people spend much less time on the problem and whether the solution actually does a tangible difference, like a 10x, 100x difference on the problem. And I would recommend anyone to spend some time just planning and thinking about this and not just thinking, oh my God, there's this super cool technology. I will be really interested in applying it. I think for an investor, it maybe makes sense to invest in startups sometimes that are just gaming around with the technology because like you can just hope that maybe they'll strike gold. But you as an entrepreneur, I mean, you might want to be a bit more strategic because you have all your eggs in one basket.
Well, thanks, Max. Really appreciate that. I'd love to move on to our signature question here at Superbio. So we ask you to imagine a future where the year is 2222. We ask you, what did AI do to our lives? Are we living forever, or is it a 1984-esque world where everyone lives under the rule of a single big evil corporation?
I actually have quite a positive outlook, mainly because like in every wave of automation, jobs disappear and other jobs spring up. And I don't know, just thinking aloud that maybe what will happen right now is that until now, all these white collar workers were very much thinking they were safe from automation because many of the things that we thought computers were good at were not quite the same as what the white collar workers are good at. But turns out that might not be the case. So many of these clerk style jobs will probably disappear now over the coming decades and will be automated away. And kind of what's kind of interesting, what is left then is very much more like the crafty work, the creative work, the just orchestrating work, and so on. And when all these boring tasks and repetitive things are done by computers, and there may be machines at some point in the future as well, which I think is a little bit further down the line, will leave a lot of space and time for us to do things that we as people care about. And we finally made the machines kind of speak our language, so we can keep speaking our language and just do the stuff we enjoy, and also make the machines do what we enjoy. I think that might be nice, quite a nice outlook.
Well, thank you. I like the optimism. Before we sign off, Max, I'd love to ask what's next for you?
So we just only launched our product in around December last year, so it's December, January. So we're still kind of working with some early adopters with like ironing out everything, and figuring out exactly how to like smoothen the process. It's a very interesting problem because, again, we're trying to make the software speak human language, not computer language, which requires us to rethink a little bit about how we interface with the tool. Then we're also in the process of securing some funding right now to grow the team a little bit more, because now we have some revenue and we're quite convinced that this is the way forward. So now we're just throwing more money at it, as you do.
That sounds very exciting, man. Thank you so much for joining the Scientist Spotlight.
Thanks for having me.
All right. Stop recording.